Welcome back. In section 10.2 we are going to solve inequalities. Okay? And there's a lot of similarities between solving inequalities and solving equations. Just like solving equations in an inequality, we can substitute an equivalent expression for either side of the inequality. Okay? We can add and subtract the same real number from each side of the inequality. So in an equation, we have been doing things like 3x plus 4 equals 7, and we've been subtracting 4 from both sides. Okay, we can do the exact same thing with any inequality. No big deal there. Okay, so that's the same kind of thing. We can multiply and divide each side of the inequality by the same positive number. So here we were left with 3x equals 3. Well, we can divide both sides by 3. And sure enough, we get x equals 1 in an equation. Well, we can do the same thing in an inequality. So if that was greater than or equal to, we'd get x is greater than or equal to 1. That would be our solution, our algebraic answer. Okay. However, with an inequality, things are a little bit different. Okay. If we multiply or divide by a negative number, we have to change the direction of the inequality. We don't change the sign, we change the direction of the inequality. But that's only for multiplying or dividing a negative number. So let's use our same example. If we had a negative 3x is less than 6, if we divide by negative 3, we have to change the direction of the inequality and get x is greater than negative 2. So we change the direction of the inequality. Okay? So we can solve these combined inequalities I have here, but we have an algebraic solution for inequalities, and you saw that algebraic solution. X is greater than 4 would be our algebraic solution. We can graph that. Okay, we can graph that on the number line. Here's 4. Using our notation in the book, we want x is greater than 4, so we're not including 4, so that's going to be a parenthesis. And change the color of my pen here. Blue. And so everything greater than 4. And then using our interval notation, if we have x is greater than 4, so 4, comma, positive infinity. So that would be that interval notation. Interval, boy, this pen's not writing very well. Interval notation. And hopefully my handwriting will improve with practice on this particular exercise. Okay? And in a little while, we'll do some sample problems. This information we don't need, so I'm going to end the show there. Here are some sample problems. Let's take a look at sample number 1. We have 14 plus 3x is greater than or equal to negative 2x. I would like to combine my x's all on one side. So what I am going to start with, we'll add 2x to both sides here. So if I add 2x to both sides, and I'm going to subtract 14 from both sides, I will get 5x is greater than or equal to negative 14. Divide both sides by 5. x is greater than or equal to negative 14/5. So here is our algebraic solution to that particular problem. There's the algebraic answer. Okay, let's go ahead and graph our solution, our number line. Okay, and our critical point is negative 14/5. I really don't care too much where 0 is. I'm assuming you know where 0 is. So I'll put negative 14/5 on our number line. And we want to include negative 14/5. So our graph will have a bracket. And we want everything greater than negative 14/5. So it's going to be everything in that direction. So there's our graphing solution. And then using interval notation, we're going to go everywhere from negative 14/5. We're including it, so again, a bracket. And all the way up to positive infinity. Oops. And parentheses. So our three different solutions, algebraic solution, graphing solution, and our interval notation. Okay. Sample problem number 2. A little bit more complicated, but not too bad. We're going to simplify the left-hand side. I'm going to distribute the negative 3 in here. So we get negative 3x minus 12 plus 2 is greater than or equal to 7 minus x. Okay, I'll go ahead and I'm going to add this x to the other side. Okay, and negative 12 plus 2 is negative 10. So I have negative 2x minus 10 is greater than or equal to 7. Now, we'll go ahead and add 10 to both sides. And we get negative 2x is greater than or equal to 17. Divide by negative 2. That's correct. I think I have everything correct here. I'm just double checking my work. Looking good. Divide by negative 2, which means if I'm dividing by a negative, I have to change the direction of my inequality symbol here. So I'm going to go ahead and do that. And divide by negative 2, I get x is less than or equal to negative 17 halves. Okay, so our algebraic solution, not a very good A there. We'll go ahead and graph our solution. We want everything less than or equal to negative 17 halves. Negative 17 halves. Again, we're including negative 17 halves. And then we want everything that's less than or equal to that. So that is going to be everything to the left of negative 17 halves. So we got our bracket. And then finally our interval notation. Pardon me. We're going to go all the way to negative infinity. And we're going to start at negative 17 halves. And we're going to include negative 17 halves. On to sample problem number 3. Well, we've got fractions in this one. This one's going to be a little bit more challenging. We've seen this before with our equations. And so the first thing we want to do is eliminate our denominator. So we look at our denominators, 3, 2, and 2. We can eliminate that by multiplying every single term by our common denominator. Our common denominator is 6. So I'm going to multiply this all by 6. And I'm going to multiply this side by 6. Okay, so now when I multiply 6 by the negative 2/3 here, I've multiplied the x minus 3. So I don't multiply the x minus 3 by 6. I'm taking care of that. That was pretty wild. I've taken care of that because of the multiplication here, the 2/3 times x minus 3. So 6 times negative 2/3 becomes negative 12/3, or negative 4 times the quantity x minus 3. Minus, I've done it here, and times the negative 1/2, so 6 times negative 1/2 is negative 3. It is less than, now 1/2 times 6, that's 3 times 5 minus x. I'm going to distribute the negative 4, I'm going to distribute the 3, so I get negative 4x, negative 4 times negative 3 is positive 12, minus 3 is less than, distribute the 3, so 3 times 5 is 15, minus 3x. Beautiful. I'm going to add 3x to both sides. I could have added 4x to both sides as well. That might have made more sense, but we're going to do that. We got negative x plus 9 is less than 15. Now you could add x to both sides. I'm not going to do that. I'm just going to subtract 9 and get the opposite of x is less than 6. And I'm going to divide both sides by negative 1, only for the purpose that I, again, have to change the direction of the inequality. Okay, I got to change that to a greater than symbol. So I get x is greater than negative 6. Okay, so my algebraic solution is x is greater than negative 6. Negative 6 is a critical point. I'm not including negative 6. So it's a parentheses and then my graph of my equation. Everything greater than negative 6. And then interval notation, again, a parentheses. We're graphing everything from negative 6, everything greater, which would give us up to positive infinity. So there's our interval notation. So once again, our algebraic solution, our number line, our graphing solution, I should say, our number line graph, and then the interval notation. So 3 good sample problems before you get started on section 2.4. We'll see you in class.